divide radicals of the same order, use the property nth root of a divided by the nth root of b equals nth root of a over b. Then rationalize the denominator. For example, cube root of 5 divided by the cube root of 2. So the first thing that we have to do is to rationalize the denominator. And to rationalize the denominator, we have to think of a radical expression that is, when multiplied both to the numerator and the denominator, would make the denominator a perfect cube root and will eliminate the radical sign. And that radical expression that we have to multiply is cube root of 2 squared, because the radicand 2 squared when multiplied by another 2 would make it equal to 2 cubed, and 2 cubed has an exponent of 3, and we also have an index equal to 3, so that would eliminate the radical sign in the denominator. And we also have to multiply it to the numerator. And then simplify. The numerator, since it has the same indices, can be multiplied. So that would be equal to the cube root of 5 times 2 squared. Same as in the denominator, which also has the same indices, would be equal to 2 times 2 squared. Simplifying this further, the numerator would be equal to the cube root of 5 times 2 squared, and 2 squared is 2 times 2, which is equal to 4, divided by the denominator. 2 times 2 cubed is equal to 2 cubed. And then the numerator, the radicand in the numerator is 5 times 4, and 5 times 4 is 20. And then the denominator, we may cancel this out, the exponent and the index, so only the radicand 2 would remain. And this would be our final answer. To divide radicals of different orders, it is necessary to express them as radicals of that same order, then rationalize the denominator. For example, cube root of 3 divided by square root of 3. So the first thing that we have to do is to express them as radicals of the same order. In our given, we can see that the numerator has an index 3 while the denominator has an index 2. And we have to make it the same order. And to do that, we should transform both the numerator and the denominator to its equivalent exponential expression. And the numerator cube root of 3 is equal to the exponential expression 3 raised to 1/3, while the denominator square root of 3 is equal to the exponential expression 3 raised to 1/2. And then we have to express these two exponents as similar fractions. So we have to take its LCD. And the LCD of 1/3 and 1/2 is equal to 6. So that would be both over 6. And then we have to divide the LCD to the denominator of this exponent and then multiply it by the numerator, same as here. Okay, 6 divided by 3 is equal to 2 times the numerator 1 is still 2. 6 divided by the denominator 2 is 3 multiplied by 1, that would still be equal to 3. And then since they have the same denominator, we can transform it back to its equivalent radical expression. So the numerator 3 raised to 2 over 6 would be equal to the 6th root of 3 raised to 2. And the denominator 3 raised to 3 over 6 would be equal to 6th root of 3 raised to 3. And then rationalize this radical expression. And to do that, we have to think of a radical expression that is, when multiplied both to the numerator and the denominator, would make the denominator be a perfect sixth root and will eliminate the radical sign. And that radical expression that we have to multiply is sixth root of 3 cube, because 3 cube multiplied by another 3 cube would have a product of 3 raised to 6, and since it would have an exponent 6, which is same as the index, we can cancel this out and eliminate the radical sign. And we also have to multiply it to the numerator, 6 root of 3 cube, and then simplify. The numerator, since it has the same indices, can be multiplied. So that would be equal to the 6th root of 3 squared times 3 cube. And then the denominator would be equal to the 6th root of 3 cube times 3 cube. Simplifying this further, this would be equal to, the numerator would be equal to the 6th root of 3 raised to 5, because 3 squared times 3 cube is equal to 3 raised to 5. And then the denominator would be equal to the 6th root of 3 raised to 6. Simplifying this further, the numerator, 6th root of 3 raised to 5 cannot be simplified anymore. So we only have to get the value of 3 raised to 5, or 3 times 3 times 3 times 3 times 3, and that is equal to 243. While the denominator, 6th root of 36, can be simplified by cancelling out the exponent and the index, and that would eliminate the radical sign. So only 3 would remain in the denominator, and this would be our final answer.